Hello everybody. Previously, we learned how PCG works at its core. In this episode, we will walk through the full PCG workflow, from generating the points, filtering them, manipulating the values and the properties that they have, and finally spawning some meshes into your scene. Every PCG system you build will basically follow the same three core steps. The first one is generating and sampling the points. So this is where you create the raw data points that you will use later in your PCG system. You can create the points by defining some positions or some other attributes for them, or you can sample some objects in your scene like the landscape or some static mesh. And after this step, you go to the second one, which is filtering and manipulation of the data. So you usually don't want to use all of the points, you just want some subset of them, or you want to modify their position scale or some other attribute that they have. So this is where you apply the rules and how you modify the data to shape up your world in the way that you want it to finally look. And at the last step, you use this data and you are spawning the objects in your scene. And this is where your points finally become real objects in your scene, like rocks, trees, buildings, or anything you want. So you can think of this like a factory pipeline. You get some points like a raw material. You modify these points at each stage of your factory process, and at the end, you use this final product to produce the actual geometry in your scene. Let's go in a little bit more detail of how each of these steps is being created. So this is the general process. We'll look into the results later, but let's look at it step by step. Let's start with generation and sampling. So the generation and sampling usually will consist of some of these nodes. So in the most basic nodes, you can create points by manually entering their position, rotation, and scale, adding values to them that you want to use, like for example, some tags or some other metadata that you want to use. You can create point grids, which is not just single specific points, but actual area or volume that's like a horizontal or vertical grid or a full volume full of points. Then you can create some point spheres by determining the position and size and the density of these points around the sphere you want to create. And lastly, you can generate points based on some static mesh objects. For example, if you have a tree that you would want to put moss on it, you want all the points to be generated in the shape of this tree trunk. So these are the nodes that you can use to generate points. You can also vault points from other sources that you have. For example, you have a Houdini scene that you generate coordinates for points, or you have a database where you use some programming code to generate a CSV file to all the positions of your points or something like this. So we'll look into that as well. Then you have the next type, which is sampling. For example, sampling a surface, which can be your landscape or some static meshes placed around the scene that form some kind of a ground plane, or for example, an interior space with tables, chairs, or stuff like this that you can place on top of your procedurally generated objects. You can sample splines in your actors to draw roads, paths, cables, or anything like this. You can sample a texture file, which you can use, for example, to draw biomes in your level. And lastly, you can sample volumes. We'll look into all of the nodes in more details in the next tutorial, which will be about generating points with the PCG. The next type I have shown here is placing points along a spline with the grammar syntax, which allows you much better control and much more complicated systems to be placed amongst points with a lot of different type of objects, and they're reacting to each other. So this is a very powerful system, but it's a little bit different than the type of workflow which you will have with creating and sampling the points. So we'll have a separate tutorial video on this later in this course. And the last type of the point generator is the custom HLSL node, where you can write actual shader code to generate the points directly on the GPU, which again is a separate type of workflow, and we will look at it into a different tutorial later in the course. So these are the most commonly used nodes for the first type, which is generating and sampling the points. And let's continue with the next step, which is filtering and manipulation of the data. I have shown some nodes here. Of course, there are a lot more, and we cannot stop right now to each one of them. But in the tutorial after the generating, we'll look into one tutorial which will be about filtering and modifying the data. And in there, I'll show you more examples. But just as a general example here, when you start with your generated points, you usually don't want all of them. You want to filter them or manipulate them in some way to actually fit the need that you have for them. For example, you want to have trees only on the flat surfaces in your landscape. You don't want to have them on the vertical cliff sides, so you can filter the points in that way. So here I have shown you have nodes that introduce some noise into your data, which you can later use to filter on. You can filter by different attributes, the density being very often used for this, because you can convert a lot of data into density values, which you can easily debug and see in your level, as you saw in the previous tutorial. So this is very helpful for you to be very sure what result you will get by just looking at in your level debug preview and filtering by the density. Otherwise, you can filter by a lot more complex filters and by different attributes that you have in your metadata of each point. You can transform the points, which is of course very often used, to change their position, rotation, or scale. And you can do a Boolean operations, like for example, the difference node can be used to match one dataset with another and exclude some of the points which are overlapping each other. Or you can just use the points that are overlapping to do something else with this intersection node, or you can combine them with the union. You have some different type of functions that will generate some kind of a real world data and save it into an attribute, like for example this distance node. It will calculate the distance between your points and save it into an attribute. And of course you have some nodes that will help you select some of the points or randomly select some amount of points or some number of points, partition your points into different datasets or merge different datasets into one dataset. We'll look into examples of this later in this course, of course, but for now just know that in the second step you do the majority of the work in your PCG system. After you generate the points, you can then have very, very complex logic to how you filter them and manipulate them, so you can achieve very good results. Everything to look like it's hand placed and crafted level, but actually it's procedurally generated on a huge map. So you don't have to do it manually. So you work much smarter and faster instead of just manual placing each object in your scene, and if you need to change, you need to redo all of the level. So we don't want that. And next, we are going into the last step. Once you have generated and filtered your points, you finally get to spawn the actual meshes. This is where your PCG graph becomes visual. The most common node here, of course, is the static mesh spawner, where you spawn static meshes in your level procedurally. And this is the same as placing them into the level like static mesh, but it will automatically take care of some of performance optimizations for you, like combine everything into instant static mesh components, so it will be much faster to load, run, and render in your scene. You can spawn actors like blueprints, for example, your enemies and stuff like this. You don't need to manually place them, you can just spawn actors procedurally. And of course, you have a spline mesh spawner, and the spline mesh spawner allow you to spawn spline mesh components which will follow the curve of the spline. Like for example, if you want to do a rod or cable mesh or something like this, you don't want just rectangular pieces spawn next to each other, you want them to actually conform to the mesh of the spline. So we'll look into a future tutorial, of course, how you can use all of this in details, because every one of them allows you to modify a lot of settings for your spawning. As you can see, you have very good control over the spawning of the different static meshes and of course actors and spline meshes. So we'll look into that into a future tutorial. So for now, make sure that you understand this basic process, that first you're doing a generation of the points. So if I disable all of the nodes here, let's enable one by one. This is the surface sampler that we get. We generate some points. We are then using a random choice, which will only select some of the nodes, or if we want to use actual density of the points, let's do a density filter instead. So this density filter will only select the points that are with bigger density than the value that you enter here. So you can see only the points that have very close to white color in the debug preview are selected. So then we'll transform the points, which will give them random rotation and scale. So as you can see here, before transforming, all of the points have the exact same scale and the exact same rotation. They're all parallel to each other. But after these transform points, they're all randomly scaled and randomly rotated. And at the end, we'll create a static mesh out of these points with this placement of this cube. So you can place any other mesh instead of this cube by changing the value here. For example, let's put some plant, and you can see we are placing procedurally some plants into our level. We can put some trees and so on. So you can see how powerful is this system and what it will allow you to do instead of manually placing each of these objects. And I'll show you different tips and tricks into every step of the process, so you can then create every system that you can imagine. And I hope that this will help you understand and work with PCG, because it's a very powerful tool. So guys, I'll see you in the next one. Bye.